What if we didn't just discover Planet 9? What if we actually went there? The idea sounds like science fiction, but it's already being discussed by space agencies and mission planners. The challenge is monumental. The destination is farther than anything humanity has ever visited. But the reward, unprecedented. A robotic spacecraft sent to Planet 9 could unlock cosmic secrets about the formation of our solar system, planetary dynamics, and possibly even dark matter. But first, we have to find it. By the time such a mission is launched, likely decades from now, we'll hopefully have a much better estimate of Planet 9's location. But even tiny uncertainties in orbital calculations can compound over time, especially when targeting an object hundreds of billions of kilometers away. To succeed, the spacecraft would need adaptive navigation. That means onboard cameras capable of detecting faint celestial objects, a propulsion system that allows for mid-course corrections, possibly AI-based trajectory planning to react in real time to slight deviations. And then comes the issue of power. At distances beyond 10 AU, solar energy becomes practically useless. Even massive solar panels wouldn't generate enough electricity to power basic instruments. So like Voyager, Cassini, and New Horizons before it, this mission would require RTGs, radioisotope thermoelectric generators. These power sources rely on the heat from decaying radioactive materials, converted into electricity. RTGs are rugged and long-lasting, operating for decades with minimal maintenance. But they produce very limited power, just enough to run essential systems and scientific instruments. This limitation means the probe must be ultra-efficient, with streamlined instruments, onboard autonomy, and robust thermal protection. And because of the extreme distance, communication delays would be enormous. A one-way signal could take dozens of hours, so the spacecraft must be smart enough to operate independently, adjusting course, avoiding hazards, and recording valuable data even when Earth is out of reach. What would this journey look like? It would be long, a decades-long cruise, possibly using a gravity assist from Jupiter or Saturn to gain speed. Depending on Planet 9's exact orbit, the trip could take 30 to 50 years, meaning the team who launches the mission might never see its arrival. But imagine the moment the probe finally approaches. A dark world slowly materializing in the starlight. Instruments flicking on. Spectrometers, magnetometers, thermal imagers, all focused on this ancient frozen giant. We could learn its mass and density, whether it has moons or rings, what its atmosphere is made of, if it emits internal heat, and whether it holds secrets tied to the formation of the solar system. If Planet 9 turns out to be a captured rogue planet, a super-Earth, or even something entirely new, this mission would offer data that no telescope ever could. And perhaps most importantly, it would push the boundaries of what's possible. Just as Voyager 1 showed us the edge of the heliosphere, just as New Horizons revealed Pluto's icy heart, a Planet 9 mission would become a flagship of exploration for the 21st century. It wouldn't just expand our map of the solar system, it would rewrite it. Of course, the obstacles are many. The costs would be high. The mission would span generations. But isn't that what makes it so compelling? To chase the unknown, to reach into the darkness, and to touch something no human has ever seen.